So hey guys, welcome back to the phase 2 of AI RAG series. So before we get started, let's just brush up what we have seen so far, and then we'll see what we have built in the phase 2. So to begin with, let's see what is RAG. So RAG stands for Retrieval Augmentation Generation. So if you see internet version of it, what it says is Retrieval Augmented Generation is a technique that enables LLMs to retrieve, incorporate new information. So what is this new information? This information lies in your local network, which is not public so far. So if you have information maybe in your file systems, maybe in your lying in your hard disk, right? So these sort of information is not public as of now. And if you want to use LLM around this data, so RAG facilitates this. So RAG has three portions: retrieval, augmentation, and generation. Retrieval is the portion wherein you would be searching your knowledge base and preparing the context that is relevant to your query. So query is something that the question that you want to resolve. Now you have the context, you have the query, and then this is called the augmentation. The moment you have these two things, you pass into the LLM model for generation. So LLM responses based on the new context that it has rather than the context that it's already trained on. So this is what RAG in nutshell. Let's see what we have built in the previous phase, wherein we had a user interacting chatbot system wherein they can upload a PDF. PDF gets processed, see the RAG pipeline flow. So we use the PyMU PDF loader. We load the PDF. Recursive text splitter, we use it to split the text. And then OpenAI embeddings is used to prepare the embeddings. These embeddings were getting stored into in-memory FastAPI. And once we have these embeddings stored, we at the time user tries to query the bot, we pick those relevant chunks from the FastAPI, pass it through Q&A chain. Q&A chain is a class provided by LangChain, wherein it facilitates the query and context support and pass and integrate it to the LLM. So in our case, LLM would be GPT-4o. We pass these to GPT-4o and prepare the final response. This was a very basic system. Though it works, but it lacks lots of features for a production grade application. So if you see ChatGPT, in ChatGPT you can log in, you can retrieve your old conversations, right? So it remembers everything that you have discussed with it. And if you upload something, it remembers what you have uploaded. The same thing is missing here. So what we tried to build the session and user management section over here. So the moment and the login section as well. The moment you log in, the login gets success, you retrieve session IDs for the users. Right? So user acted, if they have interacted in the past, they should have certain session IDs generated. You retrieve the session IDs, retrieve all the messages that were being part of that session, and populate them as a part in the chat box, just like ChatGPT does. We would be storing all these messages and everything in Postgres. Now comes the option. So initially we were storing everything in memory FastDB, but we have moved a bit advanced this time. We would be storing everything not in memory, but in actual data store. So that would be lying somewhere in my SSD. So we would be storing all the embeddings that we would be preparing, and we would be reusing them. So next time when I relog in, I don't have to upload the documents again to ask questions. This not just save processing time, but also saves us on cost, because OpenAI embeddings not comes for free, right? It charges you for preparing the embeddings. So assume right now we have one couple of documents, but assume you have millions of documents. Doing these things again and again is not optimized, right? So you have to optimize it. Once everything is stored in Postgres and FAST data store, what we have to do, we have to again do Q&A chain and pass in the query and the context to GPT-4o. It would prepare the final response. let's see a quick demo. So for demo, we have prepared two stories. Initially, we were supporting only a single document upload, but right now it's any number of documents that you want to upload, and you can just pass in the questions around these documents to the LLM. So this story is around Devi Ranta. She is a godly figure, and there is some made up story around this. This is a Gemini generated story. So only the context is residing in my local machine. There is no LM that would be knowing around this Devi and the made up story. And the second is around King Viraj, uh, the ruler of Chandragupta. So again, this is also a made up story. It has multiple chapters, right? But let's see how it goes. So in my local, we have this assistant already running. So let's try to log in. Initially, the login was not there, but now we have a login. Okay. So we don't have any old chat. I just cleared everything for the sake of demo. I'll upload something, right? Okay. This PDF got uploaded successfully. Let's try to upload something more. Okay. Okay. Nice. All the PDFs got processed. Let's ask a question. Who is Devi Ananta and King Viraj? So one thing to note, we are asking a composite question wherein one context lies from one document and another from the another document. It's not just a single document question, right? So once I post in this question, right, it's doing all the processing on the backend and see Devinenta answer is from a godly figure. She did, and the King Viraj who rules the kingdom, right? So it's able to uniquely identify which uh, documents and which context the question belongs to. Nice. So let's clear everything and log out and try to see if we are able to pick my context again. Yeah, if you see, all the context is persisted in the memory. Who is Devi Adanta? And again, I don't have to upload anything. Again, I can start the asking question from here itself. So, how many arms does Devi Ananta had? Right. So I didn't upload anything. Next time it resumes from where we have left. So this POC is what we build in phase 2. So let's see the code in next step. Okay, so let's see the code now. We have structured everything in a single workspace wherein we have backend and frontend. So the backend would be comprising of all the APIs that we need, and the front end would be having the form logic of the login and the chatbot form. So let's see the front end first, and then we'll jump to backend. Okay. So if you see, we have app.js that comprise of everything and the login.js. So login.js is just looking out for your login under this method, handle login method. The moment you press in the login, it invokes the auth login endpoint, and based on that, it is going to store your session IDs and retrieve everything, right? And app.js is the one that would be handling not just your PDF upload, but your chats and your logout, everything, every mechanic is there. So the moment you log in, it is handled. The logout is also handled here, right? Uh, okay, so the app.js would have all the logic once you log into the system. So it fetches your sessions and then you upload, right? So you upload using this upload PDF endpoint. And once you upload everything, you would need to chat. Q&A chat method would facilitate this chatting portion with the help of LLM and the context that's stored in the FAST, right? So let's see the API logic of it. And guys, as always, I would be pushing everything to the Git repo and sharing it in the description and my blog post. So just take a look around how things are working. Okay, so let's start with main.py first. So you see there are total three routers being mentioned here: routes.chat, route.pdf, and routes.auth. So let's start with the auth portion first. So we would be having our DB host, like we would be connecting to database, right? So all the connection is being maintained here. So we would be having the register endpoint. So this is what that facilitates you to register into the system. The login is the one that helps you facilitate the login. So it generates a token based on the user is having a valid credentials entered or not, right? And then we go to, once user is logged into the system, he would be shown the chat uh, area wherein they can upload the PDF, right? So to upload the PDF, we have upload PDF endpoint. So if you see, it retrieves the session ID from the request based on the session ID for the user. It takes the PDF file into the temporary memory to process it, and the process and store PDF method. Now the PyMB PDF loader loads the document. The second step is document chunking or splitting. So we are using recursive text character text splitter. This provides us the chunks. These chunks are then getting stored as in the FAISS storage. So FAISS is our vector store. So we would be storing these chunks called as embeddings against the document in the FAISS store. So let's see how it is getting stored. So this is my FAISS folder wherein the details are getting stored. Against the session ID, we can see two files are getting created, and this would be storing the embeddings. So each time against each session ID, these embeddings are retrieved, and we don't need to pre-process it again and again. We can just pick these embeddings and pass the required chunks to our context. So okay, so now everything is sorted from the upload portion. Let's see how chat is working. So for the chat, we have /chat endpoint, and it first saves the message to the database. This is being used to fetch all the data once we relog in back, so we don't miss on any message. So all the message against the user for that session is getting stored to DB. So we have created one table called messages, wherein we are storing everything, right? Okay, so once the messages are getting stored, the second step is to query the RAG pipeline. So first, what we are doing is we would be just looking out in the vector store for the similarity search. Based on the query, we see what is the best chunks that would be needed to answer this. Then we'll invoke the OpenAI chat OpenAI method that is provided by the LangChain, and we specify that we want to pass into the chat GPT-4 or mini model, and the temperature is 0. That means that we don't need any variation in the responses. We want to keep the responses as it is, and we pass in our OpenAI. And then we created a good prompt saying you are an AI assistant. Use the context to answer the question. If answer is not in context, response should be I do not have enough information. And this is the context, and this is the question that you need to pass in. Lastly, we invoke the load Q&A chain. This method is provided by LangChain, which takes in the LLM, the prompt template, and chain type. There are multiple chain type being supported. We can see there are map reduce, map re-rank, and refine. So in our use case, stuff holds good. So we'll proceed with the stuff one, and finally we'll retrieve the response. So I will be pushing all the code in my Git repo. So this is the RAG assistant repo wherein you can find complete code. And if you want to explore something more, all the POCs are present in this repository. You can find in multiple POCs and explore more. Yeah, thank you.